Welcome. This is Coach Dorf. We're in section 3.7 and we're looking at a homework-like example. In this example, we have an equation or a function that represents the position of a particle. And we're supposed to answer certain questions related to that particle. All right, so let's start off here first by writing down the equation that we're given. We're given that the position, which is represented as a function f of t, is t cubed minus 6t squared plus 9t. And it's important to realize that t is greater than or equal to 0. That t represents time, and so we could have time equal to 0. That's when right before it starts or when it starts, and then t is going to keep increasing because it represents time. So part A asks, what's the velocity? Well, the velocity then is just the derivative of the position function, which is going to be f prime of t. So I just take the derivative and I get 3t squared minus 12t plus 9. All right, so there is my velocity. Part B says, when is the particle at rest? Well, it's at rest when it's not moving. And so that is when the speed is 0 or the velocity is 0. So we need the velocity to equal 0. And so I take my equation from part A and I set it equal to 0. So now I want to factor this to find out the values of t. The first thing I do in factoring this is I notice that every term has a 3, so I can take out a 3. And then I'm left with parentheses t squared minus 4t plus 3 equals 0. Factoring out that 3 first makes the resulting excuse me, it makes the resulting factoring easier. So I factor this and I get t minus 3 and t minus 1. And when does that equal 0? That implies then that t equals 1 and 3. So the particle is at rest. It's not moving when t equals 1 or t equals 3. Part C, when is the particle moving in a positive direction? Now there's two ways you could do this. One way is to find out when is the velocity equal to 0. So I could take my velocity equation here, 3t squared minus 12t plus 9, and set it equal to 0 and find out when that's true. But I could also use the results from part B. I know that it's at rest at t equals 1 and t equals 3. The lowest value I can have for t is 0 because t represents time. So I can think of this as that the t equaling 1 and 3 is giving me some intervals. So my intervals would be 0 to 1, because 0 is where I start, 1 is where it's at rest, and then I would have 1 to 3, because that's the next time it's at rest or stops. And then the next interval would be 3 to infinity, because it keeps going, it never stops again. And I'm going to make a little table here. So on the top are my t values, and I want to know what my resulting v values are, my velocity. Is it positive or negative? And so to do this, I can just take a number in this interval, in each of these intervals, plug it into the velocity equation, and then see if it's positive or negative. Now, the easiest velocity equation to use is the last one we have, that of 3t minus 3 times t minus 1. So for the first interval from 0 to 1, I'm going to take a point in between 0 and 1, so I'll take a half. So when I do that, I get a half minus 3 and a half minus 1. It doesn't matter what the value is. I want to know, though, if that is a positive number or a negative number. And if I look at this, I have 3, which is positive. And then in the second parentheses, a half minus 3 is negative. And in the second parentheses, I have a half minus negative 1, which is also negative. So two negatives together gives me a positive. So that's positive. So I'm going to put a plus there. Then I'm going to take a number in the second interval, 1 to 3. So I'll take 2, and I'll put 2 in there for t. And there I notice I have a positive 3 minus 1 times a plus 1. So that gives me a negative value because I have one negative value. And then the last one, I'm going to take 4. And so when I plug 4 in there, I get this, and those are all positive values, so I get a positive value. So the question then is, when is the particle moving in a positive direction? So the particle is moving in a positive direction when t is in 0 to 1 union 3 to infinity. Okay, because in our table, that's when we have a positive result. Now, what does this look like when it has a negative velocity here? Well, we can make a little diagram. So if we start off with t equals 0, then we go up until t equals 1. We'll put right here. And then what happens? Well, then at t equals 1, it starts going backwards, okay, until this time, which we'll say is t equals 3. So it's moving first in a positive direction, then it's moving in a negative direction, and then it's moving back in a positive direction, okay? Like, all right, part D says, going back here, find the total distance traveled during the first 5 minutes. So total distance traveled in first 5 seconds. I think I said minutes earlier, but we want seconds here. Okay. Now, this is a common mistake that students make on this problem. They say, well, we'll start with t equals 0, and then we'll see where it is at t equals 5. Well, that's not correct. Why is it not correct? Because if we look at this diagram we just drew, for the first second, it's moving in a positive direction. After that, it's moving in a negative direction, and then it's moving back in a positive direction. If we just did the distance from t equals 0 to t equals 5, it wouldn't represent all that going back in the negative direction and then going back in the forward direction the second time when after t is equal to 3. So what we need to do here is, well, let me write this first of all. Don't do following. Don't do f5 minus f of 0. Okay. By the way, let's look at these values. What is f of 0? So I'm going back to my original function. Let's write that down here. F of t is t cubed minus 6t squared plus 9t. So f of 0, when I put 0 in there, I'm going to get 0 cubed minus 6, 0 squared plus 9 times 0, and that's going to be 0. And that makes sense. It hasn't traveled anything before it starts. What is f of 5? Well, f of 5, I would put 5 in here, okay? And do that and simplify that, I get an answer of 20, okay? So probably going to be somewhere around, let's just keep going this over here. We'll say here's t equals 5. And that distance there, you might think that the total distance traveled is 20, okay? Because the distance from 0 equals 0 to t equals 5, that distance there, here is f of 0, which is 0, and f of 5 is 20. So you might think that that distance is 20. Okay, but not. That's not right. Because again, the particle goes forward, then it goes back, and then it goes forward. Okay, so what we need to do is we need to figure out what this distance is, and then we need to figure out what this distance is. We'll call this D1, D2, and then we need to figure out what this distance is, D3. We have to add those all together. In other words, I'll look at this as the total distance traveled in 5 seconds is going to be f1 minus f of 0, okay, which is going to be d1. It's going to be this distance here. And then I'm going to have d2, which is going to be, because here's t equals 0, and here's t equals 1. And then here I have t equals 3. So I'm going to do then f of 3 minus f of 1. And that's going to give me this distance here. There's d2. And then third, I'm going to have f of 5 minus f of 3, okay? Because this is going to be like there 5, and that will give me this distance right there. Notice I use absolute values because the d2, if I just did f of 3 minus f of 1, because it's traveling backwards, it's going to be a negative number, all right? So I use absolute value because we want the distance traveled. All right, so I need to figure out some more of these values here. We know what f of 0 is. We did that up here, and we did f of 5. So we also need to do f of 1 and f of 3. So what's f of 1? So I put 1 in there, all right? And when I do that, I get 4. And when I put f of 3 in there into f, I get 0. All right, so these values here are really important in solving this problem here. And so if I look at looking at my diagram here at t equals 0, then or s is 0. And then at t equals 1, we'll put right here, t equals 1. The distance it's traveled is 4. So that's 4 units there. And then it starts going backwards. And this then here is when t equals 3, and the location of it is 0 again. So that, and then we go all the way over here, and we have t equals 5, and the position is 20. So I've got to do this in different colors. This distance here traveled, that's a d1. Okay, that's cool. Here, if I plug these values in, it's absolute value of 4 minus 0, which is 4. So that distance is 4. Then if I use green here, this distance here, this is going to be absolute value, and I'm going to have 0 minus of 1, which is 4, which is 4 also. So there we have d2 equals 4. Okay, and the last one, do in red, and here we have f of 5, which is 20 minus 4, which is, sorry, that's 0, should be 0. So 20 minus 0, which is 20. So that's that distance there, 20, and that's d3, okay? So total distance traveled is equal to d1 plus d2 plus d3, which equals 4 plus 4 plus 20, which is then 28 feet, because our distance measurement is that. Let me rewrite that so it looks cleaner. Yeah, 28 there. Okay. Again, make the mistake of thinking that you're going to do f of 5 minus f of 0. Okay, that's the displacement, but it's not the total distance traveled, because some of the time it's moving backwards. All right, that was part E. We're supposed to find the acceleration. Okay, so we need to find the acceleration. Well, what's the acceleration? Okay, acceleration equals the derivative of the velocity. So I go back, what was my velocity? My velocity again was, let's see if I remember that, it's 3t squared minus 12t plus 9. So the derivative of that would be 6t minus 12. All right, so that's the acceleration. And then the last part says when particle speeding up. So what does that mean, speeding up? Okay, well, something speeding up. Well, if you're moving in a positive direction, if you're driving a car and you're going forward, you're speeding up if your acceleration is increasing. So you have to be moving forward though. So this occurs when velocity is greater than 0 and acceleration is greater than 0, because you're going forward and you're going forward faster. So you're speeding up. But you can also speed up if you're going if you're going in the reverse direction. All right. So when does that happen? So it happens, you're going in the reverse direction. So let's see, in the reverse direction, that means that your velocity is less than 0. You're going backwards, but you're going backwards faster. So that means because you're going backwards, then your acceleration is getting even, so we have both of these. So you're going backwards in a faster rate. So think about like you start backing up a car on a street, maybe you start off slowly, but then you press down the accelerator and you're going faster in the backwards direction. So your velocity is less than 0 and your acceleration is less than 0. And you're speeding up when both of these things occur. When the velocity is greater than 0, acceleration is greater than 0, and when the velocity is less than 0 and acceleration is less than 0. So in other words, this happens when velocity and acceleration have the same sign. So we made a table for velocity. So remember, velocity table was that we had t here, and we had these intervals 0 to 1. We had, 1 to 3 and 3 to infinity, like this. And again, let me clean this up. That doesn't look very nice. 1 to 3 there. And then my velocity was positive on this one, negative on this one, and positive on that one. And we did that in part C. Let's make an acceleration table. All right. So there I'm going to have t. What intervals do I need to use here? Well, earlier we solved that the acceleration was equal to 6t minus 12. Okay, when does that equal 0? So that means then that t equals 2. So I'm going to make two intervals here for the acceleration table, 0 to 2 and 2 to infinity. And on that, my acceleration, if is equal to a number in between 0 and 2, like 1, then my acceleration is negative. And if it's in the interval from 2 to infinity, it's going to be positive. So again, to figure out when it's speeding up, I'm sure that my velocity and my acceleration have the same sign. So velocity greater than 0 when t is between 0 and 1 and 3 and infinity. And acceleration is greater than 0 when t is between 2 and infinity. So the combination of these two happens when t is in 3 infinity. In that case, both the velocity and the acceleration are greater than 0. So that was one case. Now how about velocity and acceleration both being negative? So velocity is less than 0 on the interval 1 to 3, and acceleration is less than 0 on the interval from 0 to 2. So both of those happen in what case? And that is when t is in between 2 and 3 here. Okay, if t is between 2 and 3, oops, sorry, that was right here. I meant to write 1 here. Yes, between 1 and 3. Sorry, that's not right either. Okay, let's start the over. When is this true? This is true if t is between 1 and 2. All right, and here let's check this. If t is between 1 and 2, then it's also in the interval from 0 to 2, so acceleration is negative. And if t is between 1 and 2, it's also in the interval from 1 to 3, so the velocity is negative. So, so the particle is speeding up, so speeding up on 1 to 2 and to infinity. You may ask, well, what happens on the other intervals from 0 to 1 and from 2 to 3? Well, that, it turns out, is where it's speeding down. And speeding down would represent when the velocity and the acceleration have different sign values. All right, hope that helps you.